Hi, this is Gerrit and Ommering. This is my COVID-19 data analysis. I'm looking to address three questions. One, which states are at the highest risk for a COVID-19 outbreak based on the factors of population density and urban percentage, the number of people that are living in cities. Two, how does this risk prediction compare to the actual data for COVID-19 rates in the United States? And then third, which states are at most risk for a near-term outbreak as measured by the difference between risk and number of cases to date. The first graph I'll show is population density compared to the cases of COVID-19 as a percentage of population in the various states, showing that there is a correlation between population density and COVID-19 cases on a per capita basis. In this case, as I scroll over the trend line linear, we see that the p-value is less than 0.001, showing that it is statistically significant, less than 0.005. So population density is an indicator which we would expect based on the requirement for person-to-person contact or person-to-surface-to-person contact for disease transmission. The next factor I wanted to look at related to population density is the urban percentage and its correlation to COVID-19 spread. In this case, we see that again there is a relationship here. There is a correlation, not as strong, but it's still a p-value of 0.001, statistically significant. So we do see that states with more people living in cities have a higher rate of per capita contraction of COVID-19. Of note, we can see that there are some outliers in both the sets of data we've looked at so far. New York, New Jersey specifically have a higher rate than predicted on the urban percentage. And then as we move to this next slide, we see what I calculated as a risk factor, combining urban percentage and population density, that New York remains the biggest outlier on this. So for my risk factor calculation, I tried to weight urban percentage, and I did that by raising urban percentage to the 2.5 power and then dividing it by 1,000 and then multiplying or adding that correction to the urban percentage times the population density. So this is pretty similar values wise to what we had for the population density, but it does factor in a little better, showing the impacts of urban percentage. So again, this is also statistically significant, p-value less than 0.001 with an r-squared of 0.612. So using this risk factor, what I would describe as an indicator based on the density of people for that is correlated to a risk of contracting COVID-19 in the United States. I plotted this over the map to show which states are at the greatest risk of COVID-19. And what stands out as we look at this scale, the highest values in the case of New Jersey extend above 1,000, but I did it on a 25 to 700 scale for the sake of showing color. We see that the highest risk areas are in New England and the Chesapeake Bay area, so New Jersey, Massachusetts, Connecticut, Rhode Island, and then to a lesser extent New York, Florida, California stand out as states with a higher risk of COVID-19 based on population density and urbanization percentage. Moving to the map of the actual cases factor overlaid with risk factor, we start to see a comparison of, okay, is this a good predictor of the actual rate of COVID contraction. And so what we can see is that indeed, based on the size of the circles here, there is a higher rate of COVID contraction per person, per capita, in the states that we assessed as having a higher risk factor. So in New England, we see a significantly larger rate of people contracting COVID-19. As we scan across the data, we see that New York, which I'll highlight here, has a cases factor of 237. So this is the total number of cases divided by the population, and then multiplied by a factor to make it match closer to the risk factor on scale. But generally, you can think of this as the number of cases per capita normalized to a numerical scale. So New York, despite having a risk factor of 435, is very high on the cases factor already. But we do see, as expected, a high density of case factor in the New England states and in the Chesapeake area. Other standouts that I noticed just looking at this data here: Louisiana has a higher cases factor than we might expect. California seems a little lower than we might expect. Florida seems a little lower than we might expect. And then Maryland seems a little lower than what we might expect based on the risk factor. Moving to our next slide, we see the cases factor versus risk factor. So this is a bar and bar chart, and it shows states at greatest risk factor, and then working down. So this lists all 48 of the contiguous states in the United States. So I can scroll down and see all the way down to Maine at the lowest risk factor, Montana just above that. And what we see is that many of the states aren't near the case factor density that their risk factor would predict. So whereas a state like New York has already actualized much of its risk factor, we can see here that the cases factor is more than half of the risk factor. Other states, we'll use New Jersey for an example, it's not even to a quarter of what it is. So we can see that the risk factor is above 1,200, and yet the case factor is less than 300 here. So we can see it's 209 right there. So that this goes for a lot of these states up here, that the risk factor is significantly below the case factor. So the standouts as we scan through this data: New York is relatively high in actualizing. Louisiana is very high in actualizing its risk rate. Looks like Iowa, Nebraska, Mississippi, and then South Dakota actually exceeds the list. So a higher transmission there. So I wonder what that is indicative of. It could be the commercial aspects of South Dakota that are influencing that. There's a lot of factors that could be in play there. Moving to our next slide, we see the residual risk states. So as we look at what is the difference between the risk factor and the cases factor, we come up with our residual risk. So which are the states that are at most risk for an outbreak of COVID-19 in the upcoming days and weeks? And so looking at that list, it's very similar to top 10 to what the overall risk factor was, with the exclusion of the state of New York, which has already realized many of its cases. So the top 10 lists that I see based on residual risk using the factors of population density and urban percentage are New Jersey, Rhode Island, Massachusetts, Connecticut, Maryland, Florida, Delaware, California, Ohio, and Pennsylvania. So based on this, as we look, hey, where are the places where we might want to be slower to ease off the social distancing requirements? these are the states that I would say are at most risk and that want to be the most deliberate in easing off of those protective requirements. Moving next, we'll look at a map that shows a residual risk spatially. What we can see from this is that it's the peripheries of the United States, most in the case of New England and a little bit touching into the Midwest with Ohio, and then California on the southwest, and then Florida on the southeast. So the southwest, southeast, and then near the northeast corner in New England that are at the greatest risk, with the greatest risk being in New Jersey. The references I used for this data were the Center for Disease Control. That's where I found the number of COVID-19 cases, as well as other data related to COVID-19. From the census.gov website, part of the U.S. Department of Commerce, I pulled the population estimates, which were as of 2019. And then I also pulled the land area for the states as of 2010, which I used to calculate population density. For the urban percentages, those came from Iowa State University, and those figures are correct as of 2010 based on census data. Again, the shortfalls in this data, what I think could make this project better, would be showing the impact of multi-story cities versus single-story or lower density cities. So to me, one of the great indicators for that would be the number of elevators in a city. So in a state like, or a city like New York City, where you have huge skyscrapers and giant population centers, the risk of disease transmission is that much greater. You cannot go to the store without moving through an elevator that other people who are potentially sick have gone through. You'll move through public transportation if you rely on that, where there's a greater risk of contracting the disease versus a smaller city, say in Wyoming, or a smaller city, say in Montana or in Maine, where it might be classified as a city due to proximity, but it's single story. You can stay in your home, move in a car to a supermarket, and you're limiting and reducing your exposure to other people and to pathogens. So that concludes my presentation on COVID-19. In conclusion, I think that population density and urban percentage are significant indicators of the risk of COVID-19 spread. I think that New York State has seen the worst of its COVID-19 spread, but there still is a great risk for outbreaks surging in the states of New Jersey, other areas in the New England area, as well as in California and Florida, and that these states would do well to slowly lift their social distancing measures or have mitigating factors in place to prevent it. That ends this presentation.